Hi folks, welcome to the next in our series of videos walking through how to build SAS models in Python, or just generally how to build models in Python, but models that we already built with SAS. Today we're going to be going through how to build a support vector machine, again for classification using our Titanic example dataset. You'll notice as we begin to go through all these scripts that most of them are fairly similar. You can use the same building blocks for most model types. So you'll see a lot of similarities between how we build this support vector machine model and how we built the linear regression model. Starting off with the fact that the first thing we do obviously is just import all of our libraries. You'll notice that we are importing the SVM, which is actually a module within sklearn. So we'll reference a function within that module. The reason we're doing that is because there's a number of different support vector machine type models that we could use. So we want to import the whole thing so that we have the flexibility to do all that. The next piece is obviously just some boilerplate here. Setting up the working directory, reading in the data, setting up the training and test sets, and the training and test targets, and then obviously checking the data types just to make sure that we have that all set up correctly, which we do. And the next step, we go ahead and initialize our model. If you're noticing that this is the same workflow from the logistic regression model, you would be correct. So as I said, in this case, instead of just initializing our model using a single function, we're going to have to reference a function within SVM, right? So svm.svc. SVC stands for support vector classification. There is also a support vector regression model that we use, or that we could use if we were predicting a continuous target. Support vector regression is actually not something that you can do in SAS. It's not something that you can do many places, but you can do it within Python using sklearn. So once we've gone ahead and initialized it, obviously we want to fit it. Again, to fit it, model.fit, and then we feed it the training data and the training target, and then that tells us all of the metrics that we have about our model. Right, so the training was pretty quick for that one. So let's go ahead and score it on the training data, 86%, and only 66% on our test data though. But let's go ahead and set ourselves up with a confusion matrix to see how accurate it is. So again, 0, 0 on the top and in the left column. But one of the things we can do with our support vector machine model that we could also have done with logistic regression, but that we didn't, is we can feed it different parameters. We can change the kernel type, for example, to a different type of kernel, and we can see what impact that has on training. So why don't we go ahead and create ourselves a support vector machine, and instead of using the RBF kernel, which is the default, that's what we used before, we can use any of several different kernels. We can use a linear kernel, the poly, sigmoid, pre-computed, all this other stuff, and you can find out what you can use. Actually, you can find out all of the parameters that you can use in the sklearn documentation, and I went ahead and put a link to that in the script, so that if you have any questions, you can go there, look at how this svm.svc function works, and then get a sense of why we're doing what we're doing. So I went ahead and set up a second model using the linear function, and you can see that in this case, in our confusion matrix, we've got markedly different results. So our kernel is different, that's the only thing that we changed, but now we have 198 00s correct and 75 11s correct. In fact, I bet if we did model2.score and then we put in our test x and our test y, so we get much better results. 83% correct, only 66% correct when we use the radial bias function. So I say all that to say that one of the things that you'll find as you go through these models is that tuning the parameters is very, very important. You can get drastically different results just by a simple change in a couple of the parameters. So what we do when we're creating machine learning models is we want to go through and we want to make sure that we're testing out different sets of parameters, that we're looking for the best ones, because even though your initial runs may not be that impressive, if you continue to test and you continue to tune and you continue to tweak parameters using your training set and using your test set, you can actually get excellent results, even with a variety of model types, as long as they are all tuned correctly. So that about does it for this video. Stick around, and we will have another video on some of the other model types coming up very soon.